Okay, so for number 1, it shows a numerator and denominator. You'll look at these two coefficients, 4 and 28, and then look for a common factor that you can divide both of these by. And 4 and 28 can both be divided by 4, so we divide this by 4 to get 1, and divide this by 4 to get 7. And then x cubed and x to the 4th power. All three of these x's are going to cancel out, and the reason why, I'm only going to write it out for the first example, but x to the 3rd power would look like this, x times x times x, and x to the 4th would be 4x's, like this. So write it out this first time, because the rule is only good if you understand the concept behind it, because otherwise you'll never remember the rule. Okay, so here's x to the 3rd power, x to the 4th. What happens is for every x you cancel out on the top, you can cancel it out on the bottom. So those cancel, these cancel, and we're left with 1x on the bottom. So this here simplifies to 1 over 7x, and that is our answer. And then we need to state one more thing. The denominator can't be 0, so x cannot be 0. We'll see an example where it's not. Okay, so as you know, it's going to start building now. So for number 2, we have this times this. So we're dealing with multiplication. When you have two fractions that are multiplied by each other, a numerator and denominator can cancel each other out or be simplified. So here's a numerator here, here's a denominator over here, but because we're working with just multiplication, we can still simplify those two. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Then we have x's on top and bottom, so some of those x's can cancel. So this here, we have 4 x's up here and 1 down here, so 1 will cancel right here, and then this becomes 3 x's left over. And then y squared and y, I'll just switch to a different color so it's not confusing. 1y cancels here, and then there's 1y left here. So then rewriting what's left over, 1 times x cubed is just x cubed on top. And on the bottom, we have 3y. And we're done here. And y cannot equal 0. Why do we have to write the x? Isn't it x? Well, in this case, y is on the bottom. Like, the denominator just can't be 0. Oh. Yes, Kate? Oh.
For the x, like the x to the power 4, how did it become 3?
X to the 4th power?
Yeah.
Because there was an x down here, so there was 4 x's up here and 1 x, okay. And it canceled, yeah.
So what would it be y equals 0?
Y can't equal 0.
What would that be?
I don't know. What do you mean?
Like, you always just write x doesn't equal 0 or y doesn't equal 0. When would it be it equals 0?
We'll get to an example. It wouldn't be equal to 0. It would be like x can't equal 2. We'll get to it. One thing at a time. One thing at a time. Just take in one little piece at a time. Okay. Number 3. Here we have division. I don't know if you remember to 6th or 7th grade, but when you divide fractions, you have to do keep, change, flip. Do you remember that? Keep, change, flip? Or multiply by the reciprocal. There's other acronyms, but keep, change, flip refers to keep the first fraction, change the sign, and flip the second one to get it into multiplication. So we're going to keep the first fraction. We're just going to rewrite this. 28 over y to the 3rd. Keep the first one, change the sign to multiplication, and flip the second fraction.
Is it the greatest common factor you take out?
C. Okay, now that it's in multiplication, now we can do our simplifying with the numerators and denominators, and we might look for common factors first between 28 and 21, which would be 7. We can divide this by 7 to get 3, this by 7 to get 4. And then the y squared and y cubed, both of these y's would cancel out and we'd be left with 1y on the bottom here. And the answer would be 4 over 3y. And y cannot equal 0.
Do you have to write the y can't equal 0 every time?
You're supposed to. On the homework, it'll look for the answer and they'll say, okay, what answers can y not equal? And most of the time it'll be 0, but we'll see situations where it's not. Okay. Number 4, as you know, it's going to keep building. This is 2x squared plus 2x divided by 3x squared plus 3x. What we're going to do is try to factor stuff out, and when you do that, more stuff will cancel. So for the numerator, we can take a 2x out of both those terms, so we're going to factor that out. So I'm going to take out a 2x, and then I'm left with x plus 1. And then for the bottom term, we can take a 3x out of both of those. So we're going to do that. Take out a 3x, x plus 1. Now, as you can see, we can cancel stuff out. X plus 1 and x plus 1 will cancel. X divided by x is just 1, so that cancels. And then we're left with 2/3.
There's no variable.
No. So that whole complicated thing, just simplify to that. It's kind of satisfying. Okay. Number 5. Just like we broke this up into factors, we're going to do that with number 5. But as you can see, we're going to need to factor it a little bit different, like with x plus something and x plus something else. We need two numbers that multiply to this and add to 7. And that would be 3 and 4. So our factors for the numerator would be x plus 3, x plus 4. And then for the denominator, two numbers that multiply to 8, add to 6 would be 4 and 2. So x plus 4, x plus 2. Now that it's factored out, you can simplify. X plus 4 divided by x plus 4 is just 1. That goes away. And we're left with just x plus 3 over x plus 2. And here's what you've all been waiting for, or at least Harut and Shreya have been waiting for. X cannot equal -2.
Why -2?
Because -2 plus 2 is 0, and we can't have 0 as a denominator. Yeah. Yes.
I have a question. When you wrote x plus 3 over x plus 2, can't you take out the x?
No, because you have addition there. Yes.
Can I use that?
When we're done. Can you wait 5 minutes? Out of
Is the x can equal -2 part of the answer?
Yes. Okay. Continuing. Number 6. Okay. Dealing with multiplication. We're good there. We're going to factor stuff out and then see what cancels. Yes.
What reason you didn't write y x can't equal 0 for 4? You didn't write can't equal 0 for 4. Did you just
For 4. Well, there's no x in the denominator. Like, that's just the answer. Yeah. Okay. Number 6, try to simplify as much as we can and then see if anything cancels. So x minus 2, we can't do much with that. That just stays. 3x plus 9, we can take a 3 out of both of those terms, so we'll take out a 3. We get x plus 3. This right here, 2x plus 6, taking out a 2. And then take a 2 out of these two terms. And then cancel anything that cancels. X plus 3 divided by x 3 cancels. 2 divided by 2 cancels. And x minus 2 and x minus 2 cancel. Leaving us just with a 3 in the denominator, so our answer is 1/3.
Divide across and multiply?
Because essentially it's all like 1. If it's multiplication, it's all 1. Okay, number 7. Here it gets a little bit more complicated as far as the factors go. X squared minus 25, you could say that's x plus 5, x minus 5.
Could you zoom out so I could see number 6 too?
Yeah, then somebody's going to tell me to zoom in. It's cool. Okay, so that's the top. Then the bottom, we're going to take an x out of both of those terms. So we get x minus 4. Then factor in this. Let's say 5 and negative 4 would multiply to negative 20 and add to positive x. So x plus 5, x minus 4. And then for the bottom, two numbers that multiply to 25 add to 10 would be 5 and 5. And then we cancel stuff. Okay. Thank you. Next. Okay. Now we're going to move up to the other part. Are we going to yell at me? Are we good? Okay. Number 8. Now for this one, continuing, we're going to take a 2 out of everything first. So we'll rewrite this as 2x squared plus 4x.
Can you zoom in a little bit?
See, I told you. Good. And I messed up a little bit. It's not supposed to have anything right there. Okay. Minus 12 over 2 times x squared minus 4x plus 4. Now the 2 divided by 2, that just cancels, and then I can factor out these. Two numbers that multiply to this add to 4 would be 6 and negative 2. So x plus 6, x minus 2. And multiply to 4, add to negative 4, negative 2, and negative 2. This cancels, and we're left with x plus 6 over x minus 2 as our answer, and x cannot equal 2. Okay, next. Number 9. This one is division. So before we do anything, we do have to do keep, change, flip. Keep, change, flip. So I'm going to rewrite the first one, change the sign to multiplication, and flip the second fraction. Keep, change the sign, flip the second one. Okay, now I'm going to factor stuff out. Two numbers that multiply to this, add to 7 would be 5 and 2. So x plus 5, x plus 2 over x minus 6. That's for the x squared minus 36. Anytime you see that format, especially when you have that square there. And then cancel stuff. And we're just left with x plus 2 times x plus 6. Yes, you could FOIL that out. According to your answer key, she just left it like that. So we can leave it like that too.
This when you don't need like an x doesn't equal.
Yeah, because there's no x in the denominator. And number 10, as you can see, it's kind of like a challenge one. It would be all of this divided by all of this. So we're going to write it out like that. And then for the division, we're going to do keep, change, flip. So keep the first one, change the sign, flip the second one. Then factor stuff out. So this, I can take a 5 out of those two. So 5x plus 2. Here, negative 5 and negative 3. To factor this one, we're going to have to use the more complicated method because you don't just have an x squared here. So remember the A, C, B chart. 2 times negative 3 is negative 6. B is negative 5. You get two numbers that multiply to this, add to 5 would be negative 6 and 1. So working with this over here, we would do 2x minus 6 and 2x plus 1. Do y'all remember all this from a couple chapters back? Then take out a common factor. To get these two. Okay, So we factored out this to get these two factors. I took a 10x out of here to get 2x plus 1. And now that it's all in factors, I can cancel out anything that cancels. 2x plus 1, 2x plus 1 cancel. X minus 3 and x minus 3. The 5 and the 10 can both be divided by 5, so I get a 1 and a 2. And then we're just left with x plus 2 over 2x minus 5.
Would you not take the x that's attached to the 10?
Oh, I forgot about that. Yes, you would. You'd put that x right there. Good catch. Put the x right there. And x cannot equal 0, and x cannot equal 5. So at this point, when you have like two factors in here, you put them each equal to 0. So x can't equal 0 here. And then for x minus 5 equals 0, x can't equal 5. Yes. I think, or were you the person who asked? There was somebody else who asked, wasn't there? Oh, yes, Katie too. Okay. Yes, you can go to the bathroom. Either one of you. One at a time, though. Okay. For the rest of class, you have the time to get your homework started.